Okay, so the question is asking to solve the given differential equation by hand using Euler's method. Okay, so we will use Euler's method. No? Using Euler's method with h to be 0.1. So that's the step size to be 0.1 to find the approximate values for y of x1, y of x2, y of x3, and y of x4. So we need 4 values. We need to do the iteration 4 times. So y of x1, y of x2, y of x3, and y of x4. Okay? And then we have to compare the results with the given explicit solution at x1, x2, x3, and x4. Okay, so we'll make a table and we will show what these results are. From the explicit solution, you can get the exact answers. Okay, so I don't know if you remember, I showed you yesterday how we start this. So x0 equal 1 because the initial point is 1.
Yeah.
And y0 equals 1 because he said y of 1 equals 1. And then we use the Euler's formula, right? So if you remember, and our h is 0.1, right? So so that means what's our next x? So our next x will be, so x1. Well, to find y of x1, we need x1. So x1 will be, if you remember, x0 plus IH, with I being 1 because we are on the first x. That's the initial. So that's going to be 1 plus 1 times 0.1. So that's going to be 1.1. Okay? That's our x1. And now how do we get y? We use Euler's formula. So let's write here Euler's formula in general. You have to know this. Euler's formula says y at the next point up from where you are is equal to the initial y plus the value of the function f evaluated at the point that you're at, the current point, multiplied by h. Now, what's f in this case? Right? Where f, so okay, so this is Euler's formula here. And f is the differential equation, the right-hand side of it. In this case, x cubed.
Right.
Okay. So so I can find, so so we're still on x1 now. So I could find what f of x0 y0 is. Correct?
Yeah.
By plugging in x0 and y0 in the equation. So we have x0 is just 1. So this will be 1 cubed. So this will be 1. Okay, because there's no y to plug in. Okay, and now, so now I have this, and I have the h, and I have yi. So that means I could go and find y of x1, which is the first one. So now y of x1, according to this, will equal to y of 0, because I'm finding y1, plus f of x0 y0 times h. Okay, now what's y0? y0 is 1 from the initial point, plus f is 1 times 0.1. because h is 0.1. So this is 0.1 plus 1 is 1.1. So that means y of x1 equals to 1.1. Okay? So anytime you are finding x1, those points will lag by 1 here. All of them. Okay, now we can go to x2. So x2 is equal to x0 plus IH. x0 is 1 plus I, which now I'm at 2, times 0.1. So that's 1.2. Or you could just add 0.1 to the previous x1, which is 1.1. So 1.1 plus 1 is 1.2. Either way. I like to use the general formula just because
it's easier to keep track.
Yeah. And then you're not remembering anything.
Yeah.
And now y2, or y of x2, or y2, is equal to the previous y. So that's y of x1, okay?
Yeah.
Plus f of x1, y1 times h. Okay, y of x1 turned out to be 1.1 plus f. So f is x cubed. So f of x1, y1, you substitute x1, y1 into the function. So so x1 is 1.1. So then this is 1.1 cubed times h times 0.1. So this gets us y of x2. You need a calculator on these. So let's find what that is. So we got 1.1 cubed. So 1.2331. Okay?
Yeah.
And now we can keep on going. So x3, it's very straightforward. Okay? It's x0 plus 3 times h. So that's 1 plus 3 times 0.1. We're going by increments of 0.1, so this will be 1.3. And y of x3 will equal to y of x2 plus f evaluated at x2 and x1, x2 and y2 times h. No?
Yeah.
This is just what we got, the previous answer. So every previous answer plays into the next answer. So if you make one mistake, everything down will be wrong. Okay, and then the value of f, you just plug in x2 in the function, which is y equals x cubed. So you get 1.2331 cubed times h times 0.1. And so from here you get y of x3 to equal 1.4206. Okay, you can see that we are figuring out the y values at different x's by using the differential equation without using solution of the differential equation. So that's what Euler's method is all about. So now we go to x4, which is x0 plus 4 times h. So that's 1 plus 4 times 0.1. So that's 1.4. Okay, and now we can find y of x4, which is equal y of x3 plus f evaluated at x3, y3 times h. So that's y of x3 is 1.4 1.4206 plus this, we plug in this in the original function y equals x cubed, so we get 1 point, because it's, you know, you're replacing x with 1.4206 cubed times 0.1, and we get y of x4 to be, so 1.7073, actually 29. Okay, so these are the values for y1, y of x1 through y of x4. Now, to compare them to the explicit solution, that's fairly straightforward. You just plug them in. So, okay, I'll do this in black. So the solution is y equals 1/4 x to the 4 plus 3. So now we can make a table.
Oh, it said to use 8. I didn't see that.
So this here was the approximate. And this here is the exact. The exact is coming from the explicit solution. Yeah. And so we have y of x1, y of x2, y of x3, and y of x4. Okay, so the approximates were, here, let's write them in blue since we did them in blue. So this is 1.70729. The x3 was 1.4206. And x2 was 1.2331. And the first one was, oops, acting weird. It's really acting weird. Come on. Go back to the original size. It's really annoying.
I think that probably had something to do with you left it sitting in the sun.
No, it wasn't in the sun. Hold on, I know what to do. We take the zoom feature off. Yeah, it's off. Why is it being done? Okay, let's close it and reopen it. Maybe that'll help. The zoom feature is off. Weird. Maybe because there's dust on it, I don't know. Okay, here we go, it's stable again. Yeah, the zoom feature is off, so. Okay, so we were, y of x1 was just simply 1.1. Okay, now for the exact, you just have to plug them here. So x1 was 1, so, right? So like just to show you an example, so y of 1 will be 1/4, 1 to the 4th plus 3. You just plug them in the solution. So you get 1 plus 3 is 4, 4 over 4 is 1. So you get 1. Okay, for 0.2331 to the 4 plus 3 divided by 4. Here you get 1.32 for exact 801 using the calculator. And now for 1.4, oh wait, no, the x was, sorry, the x was 1.1 here. I think I plugged it wrong. So 1.1 to the 4 plus 3 divided by 4. That's 1.11603. And this was 1.2. Right? No. 0.1, 1.2, 1.3, 1.4. Right? Hold on a second. No, the x1 was 1.1 here. This one was 1.1. So 1.1. Okay, this is supposed to be 1.1 here. So 1.1 to the 4 plus 3, because you're not doing the x0. You know the value for x0 is 1. You're doing the next one. So divided by 4, 1.1603. Now this one is 1.2. So 1.2 to the 4. Let's make this clear. Plus 3 over 4. So the next one is 1.2684. So we're reasonably close. And then the third one is 1.3. So we get 1.46403, and then the fourth one is the 1.4. 1.7. Should have wrote them in black. It's okay. 1.7104. So you can see that the approximate values are reasonably close to the exact values. However, there is still an error. If you subtract them, you can get the error between exact and approximate. Yeah, so that does it. That's how you apply Euler's method. It's a fairly straightforward problem. You wanna try one?